So guys, we'll do a series of lecture on calcium channel blocker, and in this section I will discuss about the classification of calcium channel blocker and the antihypertensive action of calcium channel blocker, or how does calcium channel blocker reduce blood pressure, right? So basically, actually this is the classification of calcium channel blocker. You can see the classification of calcium channel blocker. Calcium channel blocker can be classified into three groups. Number one is dihydropyridine group of calcium channel blocker, and in this calcium channel blocker, in this dihydropyridine group, we have amlodipine, we have sirinidipine, we have nifedipine, larcanidipine, nimodipine, and felodipine. In our country, we use this dihydropyridine group of calcium channel blocker a lot in clinical practice. And in second group we have benzothiazepine, and in the benzothiazepine group we have diltiazem, and in third group we have phenylalkylamine, and in the phenylalkylamines group we have verapamil. So this is basically the classification of calcium channel blocker, right? Now in our today's lecture we will discuss how does dihydropyridine group of calcium channel blocker like sirinidipine, amlodipine, nifedipine, or larcanidipine reduce our blood pressure, right? Before discussing about that, we have to have a very clear idea about some basic things of blood pressure. Blood pressure mainly depends on two things. One is cardiac output and another one is total peripheral resistance, or TPR. TPR depends mainly on the diameter of the arteriole, right? If diameter of the arteriole is more, your TPR or total peripheral resistance is less. On the other hand, if the diameter of the arteriole is less, your TPR is more. What factor determines the diameter of the arteriole? The diameter of the arteriole is mainly determined by the tone of the smooth muscle of the arteriole, right? So in the tunica media of the arteriole, this is a cross section of a arteriole or of an arteriole, and this arteriole consists of three layers. One is tunica intima, another one is tunica media, and outer layer is called tunica adventitia. In the tunica media, you can see clearly tunica media of the arteriole is basically composed of smooth muscle cell, right? And the tone of this smooth muscle determines the total peripheral resistance, right? So the tone of this smooth muscle determines the total peripheral resistance. This is very important. So if the tone of arteriolar smooth muscle goes up, or on the other hand, if arteriolar smooth muscle constrict, diameter of the arteriole goes down, and when diameter of the arteriole goes down, your total peripheral resistance will go up, and when your total peripheral resistance will go up, your blood pressure will go up, right? On the other hand, if the tone of arteriolar smooth muscle, right? On the other hand, if the tone of arteriolar smooth muscle goes down or arterioles relaxes, diameter of the arteriole goes up, and when diameter of the arteriole goes up, you have a decrease in your TPR, or your total peripheral resistance will go down, and when your total peripheral resistance will go down, blood pressure will automatically go down, because blood pressure equal to cardiac output into total peripheral resistance. So the basic thing is that if the tone of arteriolar smooth muscle go down, arteriole relaxes and diameter of the arteriole goes up, and this leads to decrease in TPR, and decrease in TPR leads to decrease in blood pressure, right? Now, before understanding about the antihypertensive action of calcium channel blocker, we have to have a very clear idea about blood pressure, right? In this picture, you can see various components of our cardiovascular system. This is heart, and from heart, aorta arises, and aorta branches into many large artery, and many large artery branches into many small artery, and many small artery branches into many arterioles, and many arterioles branches into many tiny vessels called capillaries, and capillaries supply oxygen and nutrition to the tissue, right? And capillaries, many capillaries join to form venules, or capillary drain into venule, and many venule drains into veins, and many veins drains into larger veins, and larger veins drains into two great veins called superior vena cava and inferior vena cava. Right, this is superior vena cava or SVC, and this is inferior vena cava or IVC, and this superior vena cava or inferior vena cava ultimately drains into right atrium of the heart or right side of the heart, right? That drains into the right atrium of the heart. So this is basically the various components of our cardiovascular system. Of these various components of our cardiovascular system, we have a portion called major arterial system, right? Major arterial system. And major arterial system consists of aorta, major arterial system consists of large artery, and major arterial system consists of small artery, and it consists up to arterial. So major arterial system extends from aortic valve up to arterial. And there is always some blood in your major arterial system, right? There is always some blood in your aorta, there is always some blood in your large artery, and there is always some blood in your small artery. And this blood in your major arterial system creates pressure in the wall of your major arterial system, right? Creates pressure in the wall of your major arterial system. And this pressure that is created by blood in the wall of your major arterial system is called clinical blood pressure, mean arterial pressure or clinical blood pressure, right? So there is always some blood in your capillary, and this blood creates pressure in the wall of the capillary, but this pressure produced by blood in the wall of the capillary is not clinical blood pressure, right? There is also some blood there is also blood in your venules, veins, and vena cava, and this blood is creating pressure. Some amount of pressure is created by this blood, but this is not a clinical blood pressure, or this is not blood pressure we measure by sphygmomanometer. By sphygmomanometer we measure the blood pressure in your major arterial system, and this blood pressure is very important, and calcium channel blocker works by reducing this mean arterial pressure or blood pressure in our major arterial system. And the blood pressure of our major arterial system depends on two things. One is cardiac output, right? One is cardiac output, and another thing is total peripheral resistance. So when our cardiac output goes up, right? If our cardiac output goes up, there will be heart will pump more blood in our major arterial system, right? More blood will be pumped in our major arterial system, and this increased blood will create increased pressure in the wall of our major arterial system. So when cardiac output goes up, there will be more blood in our major arterial system, and more blood will create more pressure in the wall of our major arterial system, and our mean arterial pressure or blood pressure will go up, right? And on the other hand, if total peripheral resistance goes up, right? If total peripheral resistance goes up, our blood pressure will go up. So total peripheral resistance mainly determines by the diameter of this arteriole. If the diameter of the arteriole is more, right? If the diameter of the arteriole is more, look at if your arteriolar diameter is more, blood in the major arterial system can leave easily, right? So if your diameter of the arteriole is more, blood in the major arterial system will leave the major arterial system will come into the venules and veins. So if your arteriolar diameter is more, or your arteriole relaxes, there will be less amount of blood in your major arterial system, and less amount of blood will create less pressure in our major arterial system. So when our arteriole relaxes or arteriolar diameter is more, blood pressure in our major arterial system will fall, right? On the other hand, if this arteriole narrows or constrict, right? If this arteriole constrict or become narrow, blood in the major arterial system will accumulate here, right? Will accumulate upstream. Heart will pump blood but in the major arterial system, but this blood finds it harder to go into the capillaries, right? To go into the capillaries. What is the purpose of blood in your major arterial system? The purpose of blood in our major arterial system is to supply oxygen and nutrition to the tissue, right? But before doing that, this blood in the major arterial system must go into the capillaries. They must go into the capillaries where oxygen and nutrition will diffuses into the tissue. But before going into the capillary, they had to overcome the resistance produced by the arterioles, right? And this arteriole is located peripherally from the heart, so this arterial resistance produced by this arteriole is called peripheral resistance. And there are many arterioles in our body, and resistance produced by all the arterioles is called total peripheral resistance, right? So this arteriolar diameter will mainly determine the peripheral resistance or total peripheral resistance. If this arteriole is narrow, blood will be accumulated in our major arterial system, right? Blood will be accumulated in our major arterial system, and this blood will create more pressure in the wall of the major arterial system. So if our arterioles narrows, right, or if arteriole constrict, there will be increased blood pressure in our major arterial system, right? So this is how resistance produced by the arterioles determines blood pressure. If the arteriole relaxes, that means if arteriolar resistance will go down or falls, blood in the major arterial system leaves easily, so blood pressure in the major arterial system will decrease. On the other hand, if this arteriole become narrow, blood or arteriolar resistance goes up, blood will accumulate in the major arterial system and blood pressure in the major arterial system will rise. Now let's see what factor determines the diameter of the arteriole. The diameter of the arteriole mainly determines by tone of arteriolar smooth muscle, right? You can see this is a cross section of arteriole, and this cross section you can see arteriole has three layers. One is tunica intima, this is tunica media, and outer layer is supporting layer is called tunica adventitia. And tunica intima is composed of endothelial cell, and tunica media is mainly composed of a lot of smooth muscle cell. You can see this red muscle, lot of smooth muscle, and this tone of this smooth muscle will create diameter of the arteriole. If this smooth muscle contracts, right, if this smooth muscle contracts, diameter of the arteriole goes down, right? Arteriole become narrow, and if when arteriole become narrow, your peripheral resistance or total peripheral resistance will go up, and when your total peripheral resistance will go up, your blood pressure will go up. On the other hand, if this smooth muscle in the tunica media of the arteriole relaxes, right, if they relax, diameter of the arteriole become more. Diameter of the arteriole become more, and if diameter of the arteriole become more, your total peripheral resistance will fall, and when your total peripheral resistance will fall, blood in the major arterial system will leave easily from the major arterial system, so blood in the major arterial system will be less, so less blood will create less amount of pressure, and so your blood pressure falls. So this is how when your TPR falls or your arterial or smooth muscle relaxes, your total peripheral resistance goes down and your blood pressure in your major arterial system will go down, right? And we record a low pressure in sphygmomanometer. Now let's see what is the mechanism of contraction of this smooth muscle of the tunica media of the arteriole, and what is the role of calcium channel, and how does calcium channel blocker reduce blood pressure, right? So this is basically a smooth muscle of arteriole, tunica media of the arteriole. You can see this is ECF, means extracellular fluid, and this is cell membrane, right? This is cell membrane of smooth muscle, and this is cytoplasm of smooth muscle, cytosol. And calcium is mainly located in the extracellular fluid, and in the cytoplasm of smooth muscle, or inside the smooth muscle cell, there is a structure called sarcoplasmic reticulum, and calcium is basically sequestered in the sarcoplasmic reticulum. There is basically no calcium in the cytosol, so cytosolic calcium concentration is tends to 0. But when this smooth muscle is stimulated, right, when this arteriole or smooth muscle is stimulated, first there is calcium enters from ECF into ICF, or calcium enters from extracellular fluid inside the cell through a channel. This is very important, and this channel is called L-type calcium channel, right? There are many types of calcium channel, but this channel is called L-type calcium channel. So basically, when this smooth muscle is stimulated, calcium from extracellular fluid, because calcium concentration in the extracellular fluid is high, so calcium from the extracellular fluid will enter through this L-type of calcium channel inside the smooth muscle, and after entering inside the smooth muscle, this calcium stimulates release of more calcium from the sarcoplasmic reticulum, right? So this calcium stimulates release of more calcium from the sarcoplasmic reticulum. So this process is called calcium-induced calcium release, and due to calcium-induced calcium release, cytosolic calcium concentration will go up, right? So cytosolic calcium concentration will go high, and now we'll see what does this increased cytosolic calcium concentration or calcium will do through an animation. You can see inside this smooth muscle there are various proteins. This is a very important protein called calmodulin, and this is myosin light chain kinase, and this is adenosine triphosphate, and this thick filament is called myosin. Of this myosin thick filament there is portion called light chain. Myosin has both heavy chain and light chain, and this portion is called light chain, and this is thin filament or actin, and there's actin is attached to dense body. This is not like typical smooth muscle or cardiac muscle. Here actin filament is attached to dense body, right? So first calcium enters through L-type of calcium channel inside this smooth muscle, and this calcium will stimulate the release of more calcium from the sarcoplasmic reticulum. So due to this calcium-induced calcium release, cytosolic calcium concentration will go up, and this increased cytosolic calcium now will bind to calmodulin, right? And then they form calcium calmodulin complex, and the function of this calcium calmodulin complex is to activate a protein called myosin light chain kinase, or MLCK. You can see there it activates myosin light chain kinases, and when myosin light chain kinase is activated, what is the function of myosin light chain kinase? It is easily understandable that the function of myosin light chain kinase is to phosphorylate myosin light chain by using ATP, right? So by using ATP, myosin light chain kinase phosphorylate myosin light chain, and when myosin light chain is phosphorylated, right, it becomes active. It becomes ready for formation of cross bridge with actin, right? It feels energized. So now it interacts with actin, and this binds with actin. Now this is the power stroke, and due to this power stroke there is contraction of smooth muscle of arteriole, right? So how is smooth muscle of arteriole is contracted basically? So this increased cytosolic calcium will form complex with calmodulin, and this calmodulin will activate myosin light chain kinase, and this myosin light chain kinase phosphorylate myosin light chain, and phosphorylated myosin light chain interacts with actin, and this is the power stroke. And due to this power stroke, smooth muscle of arteriole constrict, and when smooth muscle of arteriole constrict or shortens, diameter of the arteriole goes down, and when diameter of the arteriole goes down, your total peripheral resistance will go up, and when your total peripheral resistance will go up, your blood pressure will go up. So what does calcium channel blocker do, right? Calcium channel blocker, like dihydropyridine group of calcium channel blocker like amlodipine, nifedipine, or cilnidipine, or larcanidipine, that blocks this L-type of calcium channel on the surface of a smooth muscle. When they block this L-type of calcium channel, calcium cannot enter, right? So calcium cannot enter, and when calcium cannot enter, they cannot stimulate the release of calcium from the sarcoplasmic reticulum, right? So they cannot stimulate the release of sarcoplasmic reticulum, cannot stimulate the release of calcium from the sarcoplasmic reticulum. So there will be no calcium in your cytosol. So when there will be no calcium in the cytosol, right? When there will be no calcium in the cytosol, this process this process, the formation of calcium calmodulin complex, will not occur, right? Because it don't have calcium, right? And when this calcium calmodulin complex will not form, it cannot activate myosin light chain kinase, right? The process showed in the animation, the activation of myosin light chain kinase will not occur, and when myosin light chain kinase will not be activated, it will not phosphorylate myosin light chain, right? This process, phosphorylation of myosin light chain, will not occur, and as phosphorylation of myosin light chain will not occur, the phosphorylated myosin light chain, here you can see, interacts with actin, but when phosphorylation doesn't occur, it will not interact with actin, and this power stroke will not occur. So right, basically myosin light chain will be dephosphorylated in this state because there will not be any calcium, right? There will not be any calcium, so calcium calmodulin complex will not form. So myosin light chain kinase will be in this form, right? It will be inactive like this, and it will not use ATP to phosphorylate myosin light chain. So myosin light chain will be dephosphorylated, and in the dephosphorylated form, it will not interact with actin, so there will not be formation of cross bridges, right? So this is the relaxation phase of smooth muscle of the arteriole. And so calcium channel blocker, by blocking this calcium channel, rare type of calcium channel, prevents entry of calcium into the cytosol and thus produce relaxation of smooth muscle of arteriole. And when arteriole or smooth muscle relaxes, your total peripheral resistance will go down and your blood pressure will go down, right? So in one word, what is the mechanism of calcium channel blocker? Calcium channel blocker like amlodipine or cilnidipine or nifedipine, that blocks voltage sensitive L type of calcium channel on the smooth muscle of arterioles. And when voltage sensitive L type of calcium channel is blocked, there will be no calcium entry into the smooth muscle of arteriole. So arteriole or smooth muscle will relaxes, and when arteriole or smooth muscle relaxes, arterioles dilate, and when arterioles dilate, total peripheral resistance will fall, and when total peripheral resistance will fall, blood will leave the major arterial system, right? So when total peripheral resistance will fall, blood will leave the major arterial system, and there will be decrease in mean arterial pressure, right? So when this arteriole calcium channel blocker dilates this arteriole, relaxes the smooth muscle of the arteriole dilates, so blood in your major arterial system, right? Blood in your major arterial system will shift from major arterial system into venous and vein, and blood will accumulate into the venous and vein. So blood volume in your major arterial system will go down, and this less amount of blood in major arterial system creates less pressure in the wall of the major arterial system, so your blood pressure will fall. So this is basically the first portion of lecture on calcium channel blocker, that how does dihydropiridine group of calcium channel blocker reduce blood pressure, and I will produce one by one lecture on calcium channel blocker in subsequent portion of my lecture, because I will manage my time and produce lectures slowly, right? So thank you everyone for watching this lecture. All stay blessed. Thank you.